Okay, lab number 3 now. We're ready for that. We're going to calibrate for distance using the IIW block. Okay, there's our IIW block, just so you believe me what I'm telling you there. And then we're going to use this shear wave transducer right here. It is a 70-degree shear wave transducer. I took the transducer out. I want to put a little couplant between the transducer and the wedge. Come back to our screen here. Here's the wedge. Here's our transducer. Like I said, I'm going to put a little couplant between the two. So I'm going to take my bottle of couplant, just a drop. Don't need a lot. Okay, so just put a little drop of couplant there. And that's just to couple the transducer to the wedge. And you see it squeeze out a little couplant right there. So get rid of that. And we're going to go step by step. And I'm going to back out so you can actually see what's going on. I want to kind of back off to the side a little bit so you can actually see what's going on. It's going to make it kind of difficult to see the screen, but I think you can manage. Alright, so part number 1, step 1 says verify the beam exit point. So we need to couple our transducer to the probe. Sorry, couple our transducer to the scope. Not going to do any couple it to the probe. That's not going to do any good. That's what happens when you get on these videos. I guess your mind quits working, or it's quit working long ago, but I manage. Alright, so there's a transducer hooked to the scope now. We're going to go back to our base menu, which you can't really see that now. Base menu, range. We're going to run this range out to 10 inches. So I'm going to run it out to 10. Quicker way. Alright, so there we're at 10. Now since we're switching to shear wave, we're going half the longitudinal velocity. Okay, delays we're going to leave alone for now. We have a new transducer that is 2¼ megahertz, so we should be actually pretty close to where we were before. All that stuff, we're just going to leave it alone for now to see what happens. Okay, so I'm going to go to my IIW block. Part 1 says verify the beam exit point, which means put the transducer over the 0 point and aim it towards this edge of the block over here. So if I put a little coupling on, like that, get back over here, park over the 0 there, you should see a signal start to spike up, which you do. Bring my gain down a little bit. And all this is doing is seeing if the line, the predetermined beam exit point on the side of the transducer, is where it should be. Okay? So we peak that signal up. Look right over the side of the block here, which I'm going to take you loose for a second. So we look right over the side of the block to see if that beam exit point is right over that 0, which it's a little past, but not too horrible. Okay? Wipe the coupling off, make it a little easier to see. Alright, so we're pretty close there. That's part A. Okay? Sorry for all the rattling around here. Just need you to be right in the middle of the action. Okay, part number 2. Verify the distance, or set the distance calibration up. Since we have a type 1 IIW block, we should see reflectors at 4 and 9. And we know that because here's our 4-inch radius, here's our 1-inch radius. Couple the two together, you're going to get a signal from a 4-inch. Some of that sound's going to bounce down here, come back, going to come down again, and we're going to get a signal at 4 and 9. So, let's do that. Give it a little gain here. Here's our 4-inch signal, here's our 9-inch signal. We're not quite where we need to be. So now we go to our probe delay. Let's turn the scope a little bit to where that's at 4 inches. Okay, there's 4 inches. And we're pretty close to 9, but not perfect. So I'm going to try and make that as perfect as possible. Give it a little gain. Move our delay back. Alright. Keep coming in just a little bit more. Alright. That looks pretty close, 4 and 9. I would say so. Peaked up, looks good. So that's part 2. Now, part 3 says verify the refraction angle, which is on this side. So we're going to set that thing over the 70-degree mark. Let's turn it around here. There's 60, 65, 70, and point it towards this plexiglass disc. Okay, so we're doing that. We're just looking at this signal here. It doesn't have to be perfect. Okay, we can bring the gain down some. Just looking at where this thing's peaking up at. Excuse me. Peaking up about right there. Look down. It needs to be right over the 70, which it's pretty close. So now we know our transducer is refracting out at 70 degrees, which is good. Then the last part, part 4, says check your transducer or set your sensitivity using the 60 thousandths hole. We're going to do that right now. So set our, right there, whoa, that's plenty of coupling. Okay, we're going to set our sensitivity. So I like to start past the edge of the block. Okay, looking at the screen, back up until we see a signal jump up. Whoops. Help if I didn't lose the coupling between the two. Back up. There's our signal right there, about 2 inches. Okay, which should coincide with the 70. On the block, but the 70's on the other side over here. Alright, so there it is, about 2 inches. And now to set that sensitivity, I'm going to run my gain up to where the signal is at 50% screen height. So once it is at 50% screen height, I have set my signal, set my sensitivity. Okay, and the next part of that tells me that I need to add 8 dB and scan a weld plate. So we'll scan the weld plate in the next section. Okay? Anyway, using that, now we have calibrated to D11 on an IAW block for ultrasonics using shear wave.